Hello dear friends, welcome to BYJU'S Exam Prep, the comprehensive learning preparation app for your competitive examination. Dear friends, now learn important concepts of GATE in this Coffee with Concept series. And in today's session, we'll learn insertion in a singly linked list. Before starting the session, this is about me. Myself, Sridhar Dhulipala. I'm having 20 plus years of teaching experience and I'm associated with BYJU'S from past 2 years. And with BYJU'S, you are having double advantage, the recorded GATE content and the live video lessons. See, we created this video lessons, first of its kind, visualized animated content for you. Under BYJU'S Exam Prep app, under the category video lessons, you can find this visualized animated content which were created by us. And the following subjects were recorded by me: engineering mathematics for all the branches, whereas for computer science students exclusively discrete mathematics, C programming, algorithms, data structures. You can join my Telegram group CS_Sridhar for regular updates about my classes on YouTube as well as app. You can also join my Facebook page which is given here. Okay, so without wasting much of your time, let us learn the insertion in a singly linked list. The insertion in a singly linked list. See, the basic idea here is we manage the links to do the insertion. So the insertion can be done at the beginning or at the end of the linked list, or after a particular node, or before a particular node, or insert at a particular position, maybe third position, fourth position, or fifth position. So at that particular position, this node will be inserted. So in this particular session, I'll tell you how you do this particular insertion by managing the links. Let us see how to do the insertion at the beginning of a singly linked list. Insertion at first. Consider this particular singly linked list, my dear friends. So this is your function which actually called to insert a node at the beginning of this particular singly linked list. So you create a temporary node. The node is created. So that get node function will create the node. Okay. Then see, this is the data field and link field. The data field is updated with the value. Suppose say value is 65. The link field, because you want to insert at the beginning, what we do is the link field is updated. Now you connect the link of this temporary node to start. That is TMP link will be start. So what happened? Automatically this node becomes the first node. But you are still not able to access this particular node with start of the linked list, because the entire linked list can be accessed with start, but start is still pointing to the node containing the value 25. So we need to update the start link also. So update start link to TMP. So with this, what happened? Your new start node will be the newly inserted node. So this is how we do the insertion in a singly linked list at the beginning of the singly linked list. Am I clear? Now let us see how to insert a node at the end of a singly linked list, my dear friends. See, in this particular case, we are having only one pointer, that is pointer to the first node. If you want to insert at the end, that is after last node, if you want to insert, you need to traverse up to this particular node. So let us see how you traverse, then how you insert a new node at the end of a singly linked list. Suppose this particular function is called with the arguments, that is start of the linked list and the value to be inserted, new value which you want to insert it. Create a node, keep it ready. Okay. Now what you do? Temp data is equal to value, that is the data field to be updated. Update the data field of the temporary node, maybe 65. Link initially null. Of course, towards the end also, because it is the last node. Okay. So obviously its link will be null, my dear friends. Now what you do is you create a new pointer and you update with the value start. That is, P is now pointing to the first node of the linked list. So what we need to do, we need to traverse the entire singly linked list. That is, P should reach the last node of the given singly linked list, my dear friends. So what we do is, as long as P link is not null, we have to traverse it. Because P link is null means it is the last node. But now P link is not null. What you do? P is now pointing to the next node. P move to P link. Again P link is not null. P moves to P link. Again P link is not null. P moves to P link. Now the P link is null. Means we reached the last node. So after this node you want to insert the temporary node. Simply update the link of this P to temp. That is, P link now connect to temporary node. That is the new node. So P link now connect to temporary node. The P link is updated to TMP. So we update this particular link, my dear friends. Hope you understand. That's it. This is how we insert a node at the end of a given singly linked list, my dear friends. Of course, you return star because after insertion, you need to tell what is the linked list. The start will do what, sir? It is the pointer to the first node. See, we can access the entire linked list with the start pointer. That you need to keep it in your mind, my dear friends. Now insert after a node. See, if you want to insert after a node, you have to reach up to that particular node. Then you have to manage the links or update the pointers to insert a new node after that particular node. Let us see the pseudocode as well as the process for inserting a node after a given node. This is the given singly linked list. So you want to insert, okay, after this particular, you want to insert the value after a particular item. That item value will be given to you. Suppose you want to insert after this 55 node. That is, this is the node containing the value 55. I want to insert a new node after this particular node. So P is a new pointer which point to start. So what we need to do, as long as the P data is equal to item, you have to move P, my dear friends. Am I clear? Of course, you can create as long as P is not null, you can continue. And anywhere, if P data is equal to item. See here, why we need to say P is not null? Suppose if P becomes null, that item is not there. You want to insert after a node, but that node is not present in the linked list. Then you can say, sorry, such node is not available. So that's what, as long as P is not null, we see this. What we check? If the P data is equal to item, then we have to insert it. Suppose if P data is not item and P is not null, we just need to move P to P link, my dear friends. So this will be done. Of course, here some code will come. After this reaches the correct, that is the P reaches the correct node, my dear friends. Am I clear? So this will be updated after P reaches the correct node. So now P link is P. Again, P data is not 55. P link is P. Now P data is equal to 55. You reached the position. Now what you do? Create a new node. You created a new node. Then what you are doing? Update the links. See, don't directly do P link is TMP. By doing that, this link will be gone. So first you should not update the link of P. First what you do is, first update the link of TMP. That is, of course, TMP, that the new node data value also to be updated. Let us update the data value. The link field of this TMP now updated like this. TMP link will be, that is, this link should go to the P link. So TMP link is P link. So this will be connected to P link, my dear friends. Now this node address is with you. Now you can update this node. That is, you can update this particular pointer. You can update this particular pointer. That is, P link now point to TMP, my dear friends. P link is pointing to TMP. So with this, what happens? The new node is inserted after the node containing the data value, say 55. That is the process, my dear friends. Am I clear? That's it. Of course, after completion of your work, you have to return start. Now let us see how to insert before a node. See, in the previous case, we are inserting after the node. So P data is equal to item. You are moving. Once it is done, you insert the node. But insert before the node. That is, P link data you have to compare. Once P link data is the value, then you have to stop. Then you have to insert. See, always in a singly linked list, if you want to insert a particular node, you have to reach the pointer to a node before that particular node. Am I clear? So if you want to insert after this node, you have to reach to this particular node, my dear friends. That is very, very important point to be noted. Now let us see how to insert before node. Consider this particular singly linked list. You want to insert before this particular node containing the value item. Suppose you want to insert before 55. So if you want to insert before 55, the P should reach this particular node. That is the node before this. Am I clear? Because you want to insert before this, in between these two fellows you want to insert it. If you have pointer to this, you cannot insert before that, because you are having pointer to the next node, not pointer to the previous node. So you cannot reach P here. You have to reach your P up to 15. Then you can insert the new node there, my dear friends. Hope you understand. So let us see the process. Let us see the process. P is equal to start. P now pointing to the first node. As long as P link is not null, because the next after this you want to insert, it is not like P null. P link is null also means you didn't find that particular node containing the value before which you need to insert it. So P link is not null. Then what you do, if P link data is equal to item, then you have to do the insertion process. Of course, if it happens, the insertion process, get the new node, update the value of that particular new node, and temp link is equal to P link. First temp link is P link, then P link. That process will be exactly same as the previous process, my dear friends. Only thing is you have to take P up to this point. Okay. So initially, as long as P link is not null, and if P link data is not equal to item, see P link data is 15, I want 55. So we move P to P link. P link data is 55, you stop here. That is P stops here. Now get a temporary node, update the value of the temporary node. Now the temporary link will be P link, and P link will be TMP, my dear friends. P link will be TMP, my dear friends. So with this, you can insert a node before a given node. So if you want to insert a node before a node, we should reach to the previous node of this node. That is, we should have the pointer to the node before this. We should have pointer to the node before this. Then the insertion process is always same. TMP link is P link is TMP. That is same process. If you see, even in the previous case, the same thing happened. But where that P should point is very important. Now let us see the last insertion process, that is insertion at a particular position. Maybe second position, third position, fourth position. See, the idea here also same. If you want to insert at fourth position, you should reach third position, because after third the new node should come. So after the third node you have to do the insertion. It is same as, suppose you want to insert at a fourth position, means it is insertion after third node. That's it. So this is a singly linked list. So you want to insert at, suppose, some particular position. Let us say the position is fourth position. See, this is first one, second one, third one. So between these nodes the insertion should happen. So your P should go up to here, then the insertion happens after this P node, my dear friends. So what we do, P is equal to start. Now for I is equal to 2, that is I is actually finding the position number. So first position we don't want to insert. First position insertion is directly insert at the first. But from second position onwards, we can continue this process. I is equal to 2. Suppose if the value of I is less than position, if the value of I is less than position and P is not null, you can continue this process, my dear friend. P moves to P link. That is I less than 4, because position is 4 now. 2 less than 4 and P is not null, P moves to P link. Again, I is equal to 3 now, because I is updated from 2 to 3. I value here is 2 now. See, here we started when I value 2 here, now I value is 3. Am I clear? So I is 3 and 3 is less than position. 3 is less than 4 now? Yes. Then P is not null, just move P to P link. Now I is 4. Now I is 4. You stop. 4 is less than position. See, actually I represent the next node. I actually represents the next node, my dear friend. So you already got that position. That is, your P is pointing to the third position. P is pointing to the third position, you can happily insert a new node as you done for the previous problems. So get the new node, update its value. Now temp link is equal to P link and P link is equal to temp. So this process, if you observe, is same for almost all the insertions, my dear friends, except first and end. Generally, insert after node, insert before node, or insert at a position. Only thing is you need to reach to the previous node. Okay, if you want to insert at particular position, okay, you have to reach or you have to take a pointer to the previous node. Then the insertion can be done in a very simple manner. What is that insertion process? TMP link is P link and P link is TMP. And this is the process of insertion in a singly linked list, my dear friends. Okay. Hope you understand the process of insertion in a singly linked list, my dear friends. Okay. So you can connect to me in my Telegram group CS underscore Sridhar for regular updates about my classes. Okay. Thank you very much, my dear friends.